Awesome. How's everyone doing? Made it to the last talk. It's quite the crowd for the last talk of the entire conference, so I appreciate it very much. My name's Kyle Daigle. I'm an engineering manager at GitHub, responsible for our API teams and all of our external APIs, our internal APIs, webhooks, user identity. If you're an integrator or a customer, somehow data is coming through our neck of the woods. I'm going to quickly just talk about GitHub for those that aren't particularly familiar. GitHub is a Git distributed version control system. Basically, you put your code up on us, we'll host it. You can collaborate using issues, projects, various tools, so that way teams can work together, review code, get it deployed. We have over 21 million users, 57 million repositories. Some people pay us to host their private repositories. Other customers use our on-premise offering, so it's all completely behind the firewall. This only accounts for GitHub.com. And we're the 64th largest site in the world according to Alexa. So we have a surprising amount of traffic from around the world looking both at open source code and at private code. So enough about GitHub. We started looking at how we were working. We've done a lot of things over the years, both externally with integrators, internally behind the scenes, taking in a lot of code, making a lot of connections to a ton of different services. We looked at our current API, the work it took to keep going, and we ultimately landed on GraphQL. So spoiler alert, that's the end of the story, but we're going to go backwards a little bit in time. In this talk, I'm going to cover these 4 things. I'm going to tell you a little bit about how GitHub worked before we made a move to GraphQL. I'm going to give you a quick working knowledge of GraphQL so you can kind of understand its concepts, how you could use it. I'm going to chat about the lessons that GitHub learned by moving over to GraphQL, both internally for our own engineers and externally for our integrators. And I'll share where we are today with this and how you could get started. I intend to have a bunch of time for questions after, either with the group or if you want to come up. So if anything sparks your interest, feel free to hold it to the end. I'll answer those questions or meet with you afterwards. So I'm going to take you back a bit here and talk about how GitHub worked sort of in the beginning. So in 2008, GitHub launched our API. GitHub started around 2007 as a side project that ultimately got some traction and turned into a startup. All of our APIs were REST APIs externally. They all used OAuth for identity. We had webhooks, which were a way for us to push information to you. So when an event happened on GitHubs.com, we could send a post to your server and say, Kyle just pushed up a bunch of code. And this was the majority of our APIs. GitHub didn't really use our REST APIs. We use them ourselves for our internal tooling, like when we deploy and when we try to get issues, but we weren't using it to render any of the UI. We were just a big giant Rails app using views, JavaScript, CSS to make things work. And our teams needed to understand like the entire stack in order to build something. And that ended up being a lot over time, right? So we're still a Rails app, so ActiveRecord is our ORM for data access. Sometimes it's raw SQL, there's things like Elasticsearch, Redis, key value store, monitoring. Every person that wanted to build a feature on GitHub.com had to understand basically stem to stern how to do this thing while millions and millions of people are touching it every day, right? And so just to kind of point this out, so we have a GitHub engineer who builds a feature for our customers. They're using Rails primarily, JavaScript, no specific library, CSS, ActiveRecord to do all this. It goes out to our customers. Our customers are super excited. And then we have an interesting problem because our customers and our integrators are like, we really love projects or we really love issues, but now we want to use it on our side. Like, how can we connect with what you're building? And our engineers have to go, okay, we'll spend a little bit of time building an API for that because we didn't need it to ship the feature in the first place. And so our application engineers then go to what they built in the UI and they try and build a version of it for our REST APIs. But as we all know, what powers our UI isn't always exactly what programmatic access would want or need. And so they have to spend some time figuring out what's the same and what's different. And then they ship it to our integrators. Our integrators are like, thank you very much, we're very excited. Depending on how important the feature is, they all come in on day 1, or they wait for day 90 or day 100, and they end up adding the thing well after we're sort of done with the process.
And inevitably, we introduce a bunch of bugs in this step, right? Because it's two separate complete flows. And so the UI might work one way than the API. And we can try and factor that all out in the code to make sure that the same services classes are driving both. But we can't guarantee that that's the case every time. And it definitely hasn't historically been the case for a pretty old Rails app at this point. So what are the problems? There's a fair amount of duplicated work between our REST APIs and our internal code. When we look to scale now, it becomes very difficult because there's not a clean abstraction. We have to use our ORM. We can hope that the classes are all used in the same exact places, but that doesn't tend to be the case. REST API responses are extremely large and growing. Our REST API has been around in the current version for, I believe, 5 or 6 years. And so every time you add a new feature, you add new data, the payloads just keep getting bigger and bigger, or you break out the REST API endpoints, and then you have more and more endpoints, and you're just sort of adding complexity one way or another. And then, like I mentioned, all of our engineers needed to be near experts at scale. And obviously some solution, if we factored our code well, we could reuse it more easily between the two sections. So it's not necessarily a panacea where we ended up. There are ways to just write the code better, clearer, and share it between the two things. But in our case, it became a bit of a problem. So that was where GitHub was up until recently. Now I'm going to sort of fast forward a little bit and give a quick introduction on GraphQL. So this isn't super deep. I'll share some resources at the end where you can go and learn a bit more, but you should be able to leave with a rough understanding of how GraphQL works, what exactly it is, and then some use cases. So let's talk about normal REST. It's all endpoint based, right? Everything is, I want to get a bunch of these nouns, I want to get a bunch of these nouns. And so normally you make a request to the server, and the server returns, in our case, a JSON response, but it could be XML, whatever. So in another case that's actually a bit more realistic, let's say you want to get issue comments. You want to see someone that, see what your team has been commenting on these issues. So first you're going to go potentially get a list of the repositories, then you'll get the issues, and then you'll get the comments for those issues, right? This is like classic REST. In order to get at the data you want, you might need to traverse pretty far down. There's things like Hypermedia that tried to make this a little bit better. It was like, oh, here are all these hints where the data is actually stored. But ultimately, you're doing a lot of these round trips. And in GitHub's case, more than 60% of our traffic is just API traffic. So if we're serving a ton of requests for data that you don't actually need, it's very expensive for us to process all that when you're trying to get the one ID that you want. So in GraphQL, it's quite a bit different. You build a query, you post that to us, and you get your result back. So in one round trip, you get basically all the data that you would need to serve your request and just the data that you need. There's a couple of principles of GraphQL that I'd like to talk about real quick. The request has a hierarchy of data. When you ask for a user, and then their repositories, and then the issues, there's a natural hierarchy of the data that is both in the request and the response. You get to define that. It's product-centric. It's something that you can go and say, hey, application engineers, or hey, folks that are working on the actual product, here's all the data, the complete graph, how you can go from an issue comment all the way back to the user, to that user's repository, so on and so forth. It's intended to give the developers the tools that they need to build features on the app without having to understand where all the data is stored. There's strong typing, which is something that's very interesting coming from a language like Ruby that lacks types and moving to a typed system. Everything is typed, you have guaranteed nullability, so on and so forth. The client specifies the queries, so unlike REST, where you have a payload that you're always going to get, classic REST, where you have all the payloads, has all the data that you're going to get, you get the data that you want at a field level. You specify exactly the data that you want. I'm going to show you that in a second, so you don't get anything more. And the last thing, which is really interesting, is you can introspect the schema that you have. So sometimes there's things like JSON schema, and there are ways that we basically go, this is my REST endpoint, and here's a definition of that REST endpoint. The definition says that there's always a login, but usually that second step is an additional step if you're using sort of vanilla REST and not a library built on top of that. With GraphQL, because you define the schema, you can basically introspect that. Anyone can run a query against any GraphQL server and say, what are all of your types and how do they all relate to each other? And it's quite powerful, and I'll show you a bit more about that in a second.
But it doesn't have a lot of things, which I personally find to be really compelling, but it's worth noting. It doesn't define a response format. We return JSON, but it could be protobuf, it could be XML, it could be whatever you want depending on your use case. It doesn't define a transport mechanism. For the sake of this discussion, we're talking about HTTP, but you could use gRPC, regular RPC, whatever you want. It doesn't really matter. It doesn't care about that. And it also doesn't care about what is serving the data in the backend. A lot of other solutions basically come with complete libraries that describe, oh, you're going to expose this object in this way, and this works on top of Postgres or whatever else. GraphQL does not care. GraphQL doesn't care what you're running, what language you're in, et cetera. And it leads to some really interesting possibilities with the system. So let's look at actual stuff now. So here on your left is a very simple query for the current user, get the login. And then on the right, this is the response that you would get back from the server. So again, going back to this previous example, you're now able to send that query, get the response all in one request because that's all the data that we actually wanted. GraphQL has been around for a long time, but it hasn't been public for a very long time. So GraphQL is a Facebook technology. They use it internally kind of quietly for quite some time, but since 2012, all of their mobile applications are built using GraphQL. And then in 2015, Facebook released the specification for the community to use. It's kind of a little bit of a funny story. Lee Byron, one of the co-creators of GraphQL, gave a talk, like a tech talk, and he's like, hey, this is this really cool thing, and he shows a bunch of slides, but they don't release a spec. And the community basically went through the slides and said, well, here it is, like this is the spec. And they built some servers before Facebook had officially released a spec. And that's what Lee has said many times is very compelling about this. Like everyone got extremely excited to sort of join in on this. But it's not just Facebook. Facebook uses it, a bunch of other companies, many privately more than publicly, so it has a fair bit of backing from across the technology community. Usually with GraphQL, though, you hear a lot about mobile, because a lot of it is, I only want to ask for so much data, and on a mobile device, that's extremely important. But in our case, it's all in the UI, it's all web, and it's actually behind the server. We don't do a lot of like single page JavaScript work. We don't sort of subscribe to any particular JavaScript library, so we weren't able to say use Relay and automatically get all this stuff for free. We actually call GraphQL from within Ruby in order to give our engineers what they actually needed. So I'm going to show you another bit of an example for GraphQL. At the very top, you see a really simple type definition. The type is a user, which has a field called login, which will return a string, and again, the same exact query that I showed you before. And so at the top, I get to define the data and what it is, and then you can see, as always, the query itself is matched to the shape of the response. I sort of pointed this up a little bit before, but it's kind of important to restate why I keep showing this to you this way. GraphQL is just a query language. It's a specification of a query language and a typing system, but it isn't a library. There's no built-in anything that shows you exactly how this all should run. The community has built libraries and servers to help you sort of do this, and there's a reference implementation in JavaScript that can help as well, but there's no baked-in library that sort of comes with it, like other sort of solutions in this area where you get the whole thing and it's in whatever language, and there you have it. So now I'm sort of introducing a little bit more complexity into the system. At the very top, you can see the query. The query is just an object of that type, because there always has to be a root to everything, and so now there's a repository field that takes an optional argument called ID, which is an integer, and this will return a repository. And then you see the repository type below that. Again, the query on the left says, for this repository field, with an ID of 3, go find that and return the name. And you can see the results on the right. To look at this in a slightly different way, you're looking at the tops having the object of this root query, this entry point into the graph. And then objects can have multiple fields, or you can query multiple fields. And so you can see we go to repository, which returns a repository object, which has name, owner, visibility. And owner, for example, could not just be a string. Its return type could be a user or an organization or whatever. And so you can kind of quickly see how we're able to traverse down this graph just getting the data that we need, but also at each point potentially exposing another type. So we're defining these relationships that can sort of keep going. There's no defined endpoint. I'm going to show you a little bit of pseudo Ruby code for how this is implemented, so my apologies if this is not super familiar, but essentially we're defining this type at the top. The repository type again, it has a name of repository. GraphQL, via its introspection, you can define like a definition or a description about what you're doing. And so we add that in here in the code, and I'll show you how that sort of comes out the other side in a second. And then at the bottom we say, and for this repository type, there is a field called name, and it will have a string all the time. Lastly, we take that repository type and we stick it inside a root query. So this is where we're starting to compose the graph. The root query just being the entry point for everything that we're doing. There's a field called repository. That field returns a repository object. It has an argument called ID if you want to pass it. And then in the resolve function there, you can see basically we're calling out to ActiveRecord. This is where we're actually going and getting the data that we want. But this could be anything in there. So we're doing a simple find the repository given the argument that we gave. So going back to the initial query that we had, you can see, okay, I'm going to go find a repository with a given ID, get the name, and then you see the results on the other side. So that's sort of a very quick entry into how we define objects and how we query them. There's a couple of other things that make GraphQL a little bit powerful, but I'm just going to sort of go through them pretty quickly. You can use fragments within GraphQL as a means to basically avoid duplicating lots of bits in your query. So if you're looking at a user and on your page you always want the login in the avatar, for example, you can use these fragments to put into your query, and they basically automatically expand when the parser looks at it. So that way you don't have to, everywhere you have a user object, go, yes, and in this one I want a login and an avatar URL. Yes, in this one I want these items. So these fragments can be interspliced into your query and used as selections for the data that you actually want. You can also use fragments so you can return many types using like a union or polymorphism. So for example, the owner of a repository on GitHub could be a user or it could be an organization. And so this is one way to basically say, well, if it is a user, I want their name. If it's an organization, I want their business name. Moving a little bit into an extension of GraphQL based on Relay. One of the really interesting bits is that it gives you the opportunity to globally ID all of your objects using this node interface. The idea is that I can define a way to identify every object in my system and then obfuscate it. So that way the user doesn't necessarily need to know what these objects are, so you get this, this string here. But underneath the covers, for example, in our system, this would be repository : 3. Whatever the ID is under the covers. And so we're not using any sort of global ID in our database. We're building on top of it because we didn't start with global object IDs. So it's kind of not something very simple to add in. So what we do is we use these node IDs in order to be able to do that. The cool thing about this is every single GraphQL object that comes back can have one of these IDs. And so you can start to use these IDs throughout your system without necessarily having to go under the covers and actually add and build all these things. So a lot of times in our system, like where you would normally go from object to object or page to page, we're using this node system in order to actually get that data. And then we also have connections. Connections are how you go from one thing to many things. It's like a has many in Rails. It's a user has many issues. And so you'll see in the left side there's this repository section. I want to find the first 2 of them, and then ultimately I want to get their names. And you can see on the right side the result of that. With connections, there's ways for us to both identify the position of things, which are these cursors. The cursors are basically saying this object in this connection at this position. So if you've ever done like pagination in a normal app that uses like limit offset, for example, where you're like, okay, I'm gonna offset by this many and I want the next 100. What the cursor allows us to do is instead of going that route, which can become problematic at large
pagination offsets and get really, really slow. We can use these cursors and decide on our side if we want to use limit offset or if we want to use a different lookup mechanism, but it's all opaque to the application engineer or whoever's actually using this API. They just pass us the cursor, and we have complete control under the covers about how we want to actually get all that data. So all of this has been focused on reading data, but there's also the writing data side. And so this is a mutation. So forever we've been talking about queries, and these are mutations. Mutations are how you actually change data. And so in this example, I sort of did, if you're familiar with our reactions feature, the ability to go and be like, yeah, I liked your comment, or this is a really great pull request, all that stuff. Under the covers, the mutation for that looks something like this. And what it basically says is the react to subject is the name of the mutation. It's a field named that, and it takes an input. And the subject ID is that global ID that I showed you before, and the content is an enum called +1. So basically, I want to give something a thumbs up. The interesting thing about this is that part up top there, the middle section from subject and its contents there, is basically your ability to say, once this mutation happened, I want to run a query. And so instead of necessarily just doing like, okay, 200, you did it, or having to tell the customer like in a REST API response potentially, where you're like, okay, yeah, here's the response and here's the data we hope you want. Now we let people go and say, okay, when it's done, I want a count of all the reactions that are +1. So you can imagine like updating the UI right there and just saying, oh yeah, it's 1003 now or whatever. And so we can look at the result of this. So if you look on the right, you see sort of the result of that query. It worked, and the count went up, and there's the count because that's what you asked for. And on the left, you see a pretty simplified version of how that worked. So now, I'm going to show my hubris and show you something that's on the internet. All right. Let's see here. There we go. Okay, cool. And I will open this up like so. Okay, cool. So, hubris for sure. So basically with GraphQL, I kind of described all this to you in sort of like as an idea, but the important part is that this is all true, this is all completely live, and this is using a tool called GraphQL, which I'll show you in a little bit. But essentially, as I write a lot of this information, I can have complete control over like what data I actually want. And so for here, like we're in an issue, and I know that issues have comments. And because of introspection, the system knows that issues have comments, and so it can auto-complete the information here. And so, okay, I know I want comments, and I know, okay, it's going to ask me the first 3, and then I want, I don't want anything from the edge, I want the actual comment. I honestly don't know what's in it. Okay, so the body HTML, presumably that's the markdown of what I have here. And then I don't really know that for sure. And so I can go, okay, I know it's called a comment. Okay, there's a comment. Okay, it has body HTML. Okay, great. And I can keep looking around in all of this to be able to find out like what exactly I'm dealing in. And so I'm just kind of bouncing around, and all of this is defined just sort of like automatically by giving it a schema because of the way that GraphQL works. And so I have an author on a comment down here. So I'm going to say, sorry, I'm trying to make sure people can hear me. I have an author, and I know it has an avatar URL. And so if I go back and I start to run this, so I'm starting to get like the actual data back, right? And if I go back up to the top here, I can change, doggy food to testing, which I don't think has anything interesting in it. And so it won't return anything, and kind of so on and so forth. And so GraphQL is a really interesting way, and I think it kind of starts to show people exactly like the power of the system that we have, because I can bounce around from all kinds of things to find exactly what I want without actually knowing. So I don't think I'm very popular on GitHub, ironically, I guess. But I can pull up the information that it has. Again, I don't want anything from the edge. I want the node. And I know these are users, I think, so they have logins, right? Okay, so let's see. My first 3 followers. Oh boy, see, don't cough.
Okay. And I can see the first 3 people here, and I can continue to look into them. And I'm not going to demonstrate this just because I don't know what these people have. But for example, I could go from the user, I could look at their repositories, and I can basically climb right back up the graph. There's nothing limiting me from just going sort of in one direction. So this is graphical. A lot of the different, I'm trying to figure out where my screen is. There we go. Most of the various and sundry GraphQL users end up using this system. It was built by Facebook, but it's a very easy way to sort of start to go in and understand the power of it, not hypothetically, because it's all auto-completed, it's all via introspection. You can just go see all that there. So how did GitHub end up using it? So last March, I was having a conversation with our new VP of engineering, and one of my frustrations with running parts of the platform was that we send so much data down that nobody wants. Like, we're running these counts in these huge systems, and we're having to build fix optimization problems that help no one. Like, how do you make counts faster? Well, at some point you can't, and you have to find new ways to count, or you have to cache your counts, or if data is very expensive, you end up finding interesting ways to cache it, but ultimately the customer doesn't even want it. Most of our customers don't need that in that payload, but it was put there 6 years ago. And so we started talking about other ways that we could try and do this. Like, there's things like JSON API, if you're familiar, FileCore, there's a whole bunch of other options that generally try and solve this sort of problem. But I brought up GraphQL, and he ended up using GraphQL at a previous job. And so we decided to do a proof of concept. So the proof of concept maybe took 4 weeks, and we went end to end. So we went through our basic schema, and we found all the different interesting parts. So we can go from a user down to a reaction and have all the data there, hooked it up to graphical, and we basically demoed it to our engineering organization. And it's pretty cool because you don't have to know where all this data is stored. You don't have to worry about how to get at it. So we ended up moving it to a small platform team after the proof of concept was complete. The goal of this team was starting to look at the framework that we would need to put in, because it's very easy to be like, oh, look, I'm going to model my data, and then ultimately once you're at like 1,000 or 1,500 objects across multiple databases, it gets a little bit more complex. And so this team ended up building a bit of the schema and trying to understand exactly how it would go from the simple examples I showed at the very beginning to a much larger graph, which I kind of showed you a piece of in graphical. Then we had to add an application team. The application team being the folks that are actually building the front-end features of GitHub. We needed a way to make GraphQL work meaningfully in the app, and in a lot of ways folks turn to things like Relay or React in order to do that, but we don't sort of have that pleasure. Much of our application is still very much server-side HTML rendered, and we send it down to you. And so what we ended up doing was Josh Peak, which is part of this team, ended up building something called GraphQL Client, which is like a Relay-ish implementation to call GraphQL and get some of the benefits from Relay, but it's completely in Ruby. And so you can look at this here. Even if you're not a Rubyist or interested in this, it is very interesting, and it's helped us a lot because all of our calls are within the app and not doing much, if any, JavaScript client-side stuff. One of the other really interesting things that we did was we committed to this gem called GraphQL Ruby. So like any good developer, when you start a new project, you're like, oh, did anyone already solve this problem for us? And so we go out into the world and we're looking at various gems that are trying to solve something in this space, and we found this really great gem. And we reviewed it, we looked at all the code, the text, the licenses, and it had some things that weren't really great, but it had a lot of really good ideas, and we still really wanted to move with it. And so we decided to basically reach out to the gem author and go, hey, we're about to launch this enormous API built on your gem. Like, cool? And he's like, that sounds awesome. And so we ended up working together pretty well as we went through. And it was pretty neat because we were able to really, like, not by no means match Robert, who you see in the top left. But we were able to add a fair bit of code to it and help get this thing going. So the bottom two folks are two of the top contributors for this project now. Garin and Josh both work at GitHub. And so it was very interesting to take on an external gem, and instead of necessarily forking it and being like, oh no, we're going to do our own thing, we sort of committed early to wanting to upstream everything because it was important for us that GraphQL was successful holistically and not just good for us, because if it's good for us and bad for all of you, it's going to die. Like GraphQL technology will sort of die on the vine. Around July, we had our first internal usage of this within our applications. So when we launched projects, that was all completely backed by GraphQL. A lot of things went into that, and a lot of sort of new ideas and frameworks and best practices like I talked about. But the cool thing was that it was our first real effort into a new feature completely locked in on GraphQL. And then at September 14th at GitHub Universe, which is our premier yearly event, we launched the first large-scale public GraphQL API in early access. Folks were really excited, extremely confused. They were trying to wrap their heads around what exactly this means. And we also launched the GraphQL Explorer, which was the thing that I showed you before, with a safety screenshot in case the whole thing went belly up. And so you can see on the left again all the queries, the results, and then the far right, all the documentation that automatically comes from the introspection query that GraphQL does based on those definitions that we had. One of the really interesting things was that while we were on stage talking about GraphQL, we basically said, and here are the gems we used to build this thing, because it wasn't all us. We were building on top of Robert's work, and Shopify had an open source gem that we used. And so when we shared those libraries, it was pretty interesting because somebody else tweeted this a couple of months ago. But basically, you can kind of see in the late summer when we start to sort of pick up and try and add some stuff, and then we announce it on, I think it was September 14th or so, which you can see the giant spike of people suddenly contributing back to this gem. And then the whole community, everyone that's using GraphQL and using this gem, got to take a lot from that. And the community just jumped right in because it was very interesting and compelling. And it felt pretty cool. Robert was very excited, and we were happy to be able to, be a part of making some contributions back and highlighting to the community that this was something that was very compelling. I'd be remiss if I didn't call this out. You can go to developer.github.com to read a lot more about all this. But what are the things that we learned during this early access period? When we shipped it on stage, we basically said, go give this a shot, but we're going to break it all the time. We have no promises to you that this thing will keep running, that we don't really know if we're going to make mistakes that we need to change. But it kind of didn't matter. There was a bunch of really interesting use cases because folks were able to get at data a lot more quickly and a lot faster than we could provide. And so we also continued to use GraphQL heavily internally. By the end of last year, we were writing all of our new features completely on GraphQL instead of using the more ActiveRecord direct approach. And we got some wins that I kind of want to talk about a little bit. So normally when we look at making these queries, or trying to access data, we're looking at different ways to manage the authorization of getting at that data. And we're doing it via queries. Sometimes there's libraries that check every object and do that sort of thing, just to make sure that users can see the thing that they want to see. In our case, because we run a public service, spamminess is also a very interesting problem for us because we want to show spammers their content, but we don't want to show non-spammers spammy content. It's a way to make sure that spammers don't find out that we know they're spammy by showing them their content. And so it becomes this interesting problem because those types of rules are not evenly applied across a system that is 10 years old. And so we added this object level ability checking. So if you look at the bottom query here, you see the viewer. The viewer happens to be a user. It's me. I want the first 3 repositories that I have. In the top section basically just demonstrates, this is roughly how the system underneath is building this graph. And so once we get all those, we can then go through and basically say, all right, should you see all these things? Ooh, no, we shouldn't see that last one. Because when we have these objects in the graph, we can run checks on them as they come back and not necessarily rely on 2 things. 1, that the system was correct when it got the data, and 2, that the developers who wrote that system were correct. Because it doesn't work if everyone has to know, oh, don't forget, you have to check if it's spammy, and they don't, or you have to check that this is public, and they don't. And so this system allowed us a way for in both development and production to ensure that there's a consistent set of rules applied to all the data, because we know what this object is, we know that it came back, and we know the rules for user objects and repository objects. One of the other interesting problems, problems that ultimately came to a solution was that
performance improvements are applied everywhere you try to access a single object type. So in most applications, you're like, I want to go get these repositories, and then over here I'm going to go get these other repositories. But instead, because of the way that the graph works, when you get to a repository, we share that lookup across the entire system. And so that lookup can be optimized, changed, improved over time in ways that are completely separated from how you're calling the query, that no one knows this is happening. Suddenly the query just gets immensely faster because we don't have to make that improvement across the entire system. I would say we learned a valuable lesson not to underestimate training and documentation. It took a fair bit of time to get everyone up to speed internally, both because GraphQL is new, it's not as well known as something like Rails or REST practices, so on and so forth, but also needed to spend a fair bit of time getting people comfortable with the old way was this way, the new way is this way, how do I get from A to B? And so we're still spending more time making this right. We wrote an internal tool, and some of this is replicated externally. And so you can get to internal documentation that shows how GraphQL works with us, how GraphQL works externally, and a little bit more about how GraphQL itself operates, because you can see in like the bottom left there we have some stuff that actually shows the objects, etc. This is all built on an open source library that one of our engineers wrote, so if you end up deciding to go with GraphQL or you use it already, there's a library that can help you generate some of this documentation. The other thing in our case is our platform engineers are not the ones building the schema. We let anyone in the system build schema. If you add a new feature, like recently GitHub released a topics feature, when that feature was built, the platform team was just responsible for the framework, the tools, the plumbing in order to do that. The team that worked on topics built the schema, the resolvers, and everything else. Because it's essentially impossible to have a team that's going to create all of the objects in the entire system. With that though, you want to make sure that your schema makes sense. You want to make sure that the resolvers aren't bad from the very beginning, that the data that you're trying to get isn't going to be imperformant from the very start. And so we wrote a bunch of RuboCop, which is just a linting library and Ruby tools, so that way we run a specific CI build that's just for these sort of errors. And so the engineers can see them, and because the linting library supports it, if you use an IDE that supports it, you can get those errors in your local development as well. So this really helps us because otherwise we're relying on humans to catch problems, and that's rife with its own issues, but it's also an enormous scaling problem. The application engineering organization is a lot larger than the platform organization that's responsible directly for GraphQL, and so linting helps a lot. One interesting problem is if you're familiar with REST and OAuth, trying to go from a REST situation to a graph situation and bringing in scopes as an authorization mechanism kind of sucks. Because with REST, you're building an endpoint and you know exactly what data is going out, and then you say you need this scope to access this endpoint. Graphs don't work like that. It's sort of like going into a city and you're trying to go down different roads, and as you go, you just suddenly can't take a left turn. There's just a sign there, right? And so with OAuth, which we're bringing to the GraphQL API, it ended up being interesting because it was a bit more complex because of the way where the graph can recurse on itself, essentially. You can go, I want a user, their repository is the owner, which is a user to the repository, so on and so forth. But also because we can basically annotate all the objects in the system with the scopes that are necessary, which got us to build this really interesting thing, which was kind of difficult to do in a normal REST endpoint, because in a normal REST endpoint you say, you need this scope, you don't have it, go get that scope, you're good to go. But in this we can say basically, hey, the token that you built is trying to access this field called name, but it requires this scope called read org, and this scope this token only has user repo. Like, go add that and your query will work. And we can do this at the very beginning because of the type system in GraphQL. We can do it in a static analyzer to basically say they're trying to get these types, those types need these scopes, the token doesn't have those scopes. And so before we ever hit the database, we can go, stop, nope, and then we say, here are the scopes that you actually need to do that. And so it's one of those things where it's a somewhat inelegant solution to the problem, but it helps us avoid processing any data before we know you can, because we spend a lot of time doing that right now. Our use of GraphQL is powerful, I think, primarily because it's the single interface.
if you read anything about us like doing this, or a lot of people who do GraphQL mention it because of the public side, the interesting thing I think is that we're using it both internally and externally. It's the only way to get at data. If you're an integrator or you're an application engineer, you're using the same exact GraphQL APIs to do that. And that gives us a bunch of power. It also adds a bunch of complexity. But in our case, it gives us the opportunity to only have to worry about one thing. So when a feature goes out, like topics, for example, we have a day zero API that works out of the gate, and we're sure it works because it's the same thing that's powering our stuff, plus some extra that we think integrators might want. The normal question that we end up getting after describing that is REST dead? And I absolutely do not think so. I think that REST has a lot of things going for it. It's just not exactly what we need. So I want to kind of cover it just because everyone thinks when we say we had a REST API, now we're investigating a GraphQL API, that we're like putting the nails in the coffin in REST. That's just certainly not the case. REST is great when you have majority control over the data that you want to provide. And so if you have a simple external API, you have a mobile application where you can have complete control over the data that you need for that view, REST works great for that. You're not going to get any additional benefit. REST is a ton simpler. Most every library can go, given an object, render it to JSON, boom, you have like 80% of a REST API. With GraphQL, though, it does provide you more data, more information in the way that the audience wants it when you don't know how they want it. Right? With REST, you can have complete control, and GraphQL, one of the benefits is query us however you want. We don't need to know in advance. You do what you need to do, and we'll protect the system underneath. And so GraphQL requires you to handle those changing queries. We do not know how we're going to have our data requested in advance. With REST APIs, you know, okay, these 4 queries are going to run. They might be big, they might be small. With GraphQL, it's how complex is this query? How much data is it trying to get at? So you're kind of paying one thing to get the other. How's it going now? So now we have a very big rule. All new feature development must be in GraphQL. This has really sped up our learning and also helped us find a lot of places where we're not doing a great job of explaining how systems work. When you're saying to everyone, hey, you have to use this system now, suddenly the folks that were maybe not as interested now have to, and you find a lot of ways that you can make things better. The added benefit of this is all the features that come out now have GraphQL APIs on day one. And so when you hear us go, hey, we just released this new thing, there's a GraphQL API for that, guaranteed. Which is very interesting for both you and integrators, because previously you would have to wait 30, sometimes 60 days to get a REST API, and it might not be exactly what you need. And so it's had some upsides and some downsides. We're actively moving our old features over, so if you think of things like our dashboard, notifications, the pull request page, like those pages have so much data, and if you think of like a data dependency chart, it's extremely complex to lop off a piece and go, I'm gonna build this one piece in GraphQL but leave the rest as it is. It's basically, okay, I'm gonna build this whole thing in GraphQL. And so it takes a lot more time, but we've been able to tease out a fair bit of those subsystems that we've needed. We're beginning a separation from ActiveRecord, which is our ORM in Rails. And so instead of necessarily having to use ActiveRecord under the hood, we can move to things that aren't just ActiveRecord in MySQL a lot more easily without having to train every engineer at GitHub and without necessarily having to tell them, you know, hey, your data is now living over here. Behind the scenes, we can just slowly move data into whatever system that we want without anyone in application engineering needing to do that. So we can get to a more resilient, highly available setup without necessarily having to train everyone to do that. And so GraphQL becomes a way for us to separate these concerns. There's tons of other ways. You know, there's different systems. If you just have a good abstraction layer, you can do that. For us, this was an easy way to give the product folks what they wanted and what they needed, but also make sure that the thing kept running under the covers. So that is the quick story of how in a year and a half we're basically moving completely to GraphQL internally and externally. And now how can you get started? And so the easiest place to start is GraphQL.org. It's a really great community site, primarily maintained by Facebook, but also the other companies and people in the community that are interested. It has documentation, all the different libraries depending on what languages you primarily use. That's really great. LearnGraphQL.com is a really cool site that someone built that basically can walk you through with some interactive examples of saying a much more extended version of what I did at the very beginning of the talk, showing the various queries. One thing that I tell people is if you do have a REST API, you can actually build a GraphQL API on top of it pretty easily, especially if your REST API is very nounful. Like if it's a real REST API where it's repositories ID, issues ID, you can basically just put a GraphQL veneer on top of that, which makes it an easy way to test it without necessarily having to convince everyone under the covers to say we should move everything over to this. If you do already run a public API, it's very interesting just to Google this because there's a lot of people who build these for fun. And so before we launched ours, we were like, oh, let's go look. And it's like, oh, we already have a GraphQL API that we didn't build. It's just built on top of our REST API. And it's even true for small startups all the way to large companies. So it's something to look at and an easy way to get your feet wet, even if it's like on the side and not at work, because you can get all the data you want but still query it the way that you'd be interested in. So this is really cool. This is called GraphQL Up. I'm going to show a video real quick as I talk about this. So this is a tool from, let's see, oh no. This is a tool from GraphCool. Is this going to work? Yeah, there we go. This is a tool from GraphQL, which is a service that basically does GraphQL as a service. And the idea here is if you install their command line tool, you can pass it a very simple GraphQL schema, and they're going to give you one just in advance. And you'll notice it's just basically like the definitions I gave you. No resolution. They're going to take care of sort of fuzzing that in the back end for you. And you essentially just upload it to them, and then they'll give you a completely fully functional GraphQL API that you can give it a try to. So it's a really easy way to basically focus on the type system that you want, like, oh, I'm going to have a user, and a user is going to have a repository, and then the repository is going to have issues, or whatever makes sense in your world. And then you just use this one little command line tool, and they'll host an API with documentation. This is called GraphQL Up. Very cool way to get started without actually doing any programming. You're basically just writing into the IDL. You can give it a go with Relay or Relay Modern. Both work really well. So if you're into that space with React and Relay, it's pretty easy to use GraphQL on top of that. It does a lot of really interesting caching works. That way, if you already have the object, it's not going to go try to get the object again. It takes care of a lot of different optimizations. And it provides a lot of sugar on top of GraphQL that you would otherwise have to implement. So if JavaScript or the front end is more your jam, check out Relay because it's baked in. You can also look at Apollo, which is a similar idea, separate company that does a separate library for that. And if you just want to play with a GraphQL API, developer.github.com. Our GraphQL API is public. You just have to have a GitHub account, pop your credentials in, and you can get all the data that you'd want. If you do it, I want to hear about what you thought, or if you try to use GraphQL yourself, please message me. I'm at Daigle on Twitter and GitHub and everywhere on the internet, or email me, kdaigle@github.com. Thank you so much for staying for my talk this late. Thank you very much. I'm happy to answer some questions. I also have the requisite GitHub stickers up here, if that's your thing. Yeah.
Thanks. So if GraphQL is just a query language, what and where is the translation between GraphQL and VORM? And how does that get turned into SQL, presumably in this case?
Sure. And so with that, essentially, we use a library. So the GraphQL query itself, part of it has a rule, has rules for how you need to parse that query into ultimately an AST, and then how you execute that AST is up to you / your library. And so for us, essentially, we use this GraphQL Ruby gem that essentially says at each point in the graph, we kind of work our way in, so that way we can optimize the data loading instead of going in, and then you end up with n+1. So we kind of go down and in. And so in doing that, we create these things called resolvers that essentially say, you're asking for current user, we know the current user is this person in the session, the resolver returns that user in the session. And then when I ask for repositories, the repository resolver knows that it's gonna say for potentially an ActiveRecord, repositories where current user is this user. And then we go down one more level, and if we look for issues, then we have a repository object that we then go to ActiveRecord in a resolver for that field. And so these resolvers do a lot of this for us, and we manually program them. I forget the name of the project, but if you use Postgres as your primary database, you can essentially generate this entire thing for free, assuming your data model is good and you're not trying to hide anything. There's a lot of different ways to automate those, but they're ultimately called resolvers, and they go in any language from when you ask for the object itself, you get the field, you resolve that field. And so in our case, for example, we might be hopping between Elasticsearch and MySQL pretty heavily, and then eventually going to Memcache. And in each of those resolvers are taking care of that for us. In a production system, you have to deal a fair bit with batching all of this up. And so we use like a promise implementation in Ruby, which allows us to say, like, we know we want this user, we know we want this user, and then eventually we go to the database and get those. If you're in JavaScript or Scala or anything else that actually has concurrency in it, you can do a lot more interesting things. But yeah.
So now that you have GraphQL as the main place where you're exposing new features that you develop, you still have this REST API that a bunch of people are already using.
Yep.
Do you still have that policy of like, we're going to take 60 days and add this into the REST API afterwards? Or do you add like an adapter that REST can now automatically use GraphQL and like inherit new features?
Yeah, so I would definitely want to clarify that there wasn't a policy of 60 days. It was like an accident, but nonetheless, yeah, so we still completely support the REST API, and we still bring all these features to it. And so the interesting thing is that essentially what we do under the covers now is we write GraphQL queries in order to do the REST query. And so with newer features like projects, for example, those APIs, when they came out at the very beginning, all ultimately go, it's a REST request, run this GraphQL query, send it through the REST serializers, and send the result back. And so we have these patterns that we're working towards that way we can get more of it for free. I think you'll notice that like in the new REST APIs that we build, they tend to be thinner. They tend not to be so sort of verbose and all over the place because we're just going to GraphQL to get the data that we need, but we intend to keep doing that, so that way you can still use that REST API that we have, because it has been around since forever, and add the new features to it. But the problem that we had before, where we had to convince these engineers to go over there and do that, or try and find new make sure they can expose the data in a way that they understand and were prepared for. Now they already have that, and so we're like at an 80% solution with the REST API, and then you just have to do that last 20%, which does the sort of mapping from a GraphQL response in process to a REST response.
So it makes the development of new REST features a lot easier, really, than before.
Yeah, and I mean, if you were to start today with GraphQL and go to REST, I think there's a ton of ways where you could get a free REST API in ways that just don't work for us because we already have a substructure and framework. But yeah, I definitely think that way is better than the other way, where you have a REST API and you're building GraphQL on top of it. Totally doable, but you're hiding the round trips and the potential problems if you try to do it that way. So I think the other way just makes more sense. And then you can still provide all the REST API endpoints via noun without having to do all the lookups again, or making sure you're exposing the data that integrators would want or whatever.
Thanks.
Yeah.
How do you handle schema changes, specifically backwards incompatible changes?
Sure. So GraphQL has this very romantic notion that there are no breaking changes. That isn't true. But if you go online and you read about GraphQL, primarily that is the answer, is that when you make a change, the fields can't actually change. You just addend. So like if you have a field that you want to get rid of, you add a new one, and you try to move people over to that. There's two ways that you can do that sort of out of the box. One, you can annotate fields as deprecated, which based on the calls, the client tooling, etc., will eventually start hiding them.
under the covers, what we do is if you start calling deprecated fields, we know, oh, this customer, this integrator is calling this deprecated field. So we can sort of do like a back-off approach to say, hey, we know you're calling this, it's gonna go away, warning, warning, and we can get more aggressive as we go. In terms of actual breaking changes, to be honest, there's no good way. Like, the one good way that Facebook generally does, if they have to do this, is they make all their fields nullable. So I very quickly touched on the fact that you can say, this string will always come back, this user will always come back. Facebook's schema does not use that. Everything is nullable. So a breaking change would be telling the end user, warning, this could always potentially be null. And so when you have that case, when you give that warning from day one, you don't get the benefits of knowing for sure that a user is going to come back, but when nothing comes back, then you're prepared for that case at any given moment. And so that's one potential option for the breaking changes bits. To be honest, to go from the early access to trying to get more and more in, we're still in a phase where we're trying to figure out what is the most gracious way to do a real breaking change. Most of our breaking changes for the REST API have always been security related, where it feels mildly okay to just be like, oops, crap, this needs to go away. But I think this is one of the things that we're sort of figuring out and hopefully can share with the community as we go, because that is one of the things that sounds super great internally, but externally, it seems really unreasonable to be like, repository name, real name, name v2, the super real name, which is essentially how internal schemas at most of these companies evolve over time. So we're working with the folks at Facebook and the GraphQL folks to try and find better solutions, but hopefully we can share more as we actually end up breaking stuff in the next couple months.
Question. When you're sending a request, a query in GraphQL, is it possible to work with multiple, an easy way to reference a schema if you have multiple schema to select from for a given request?
So the way we do that right now is we essentially have one enormous schema, but we're only comfortable sharing this much with you right now. So we'll just say 20% out of 100%. And so most of the libraries that use this have a various type of whitelisting, scrubbing, warden system that basically says these types we're not comfortable exposing ever or potentially right now as we're doing internal development. And so that allows us to do it on that level. In terms of actual multiple schemas, sometimes what folks will do is that they will have the root query object, a field, and then that field is actually the entrance into a completely separate schema, if that makes sense. This is really big if you're composing multiple services and you want sort of a proxy GraphQL layer. That is a piece. You can define multiple queries and operations in your single request and then just say, right now I want to run this. So you can say query A, query B, query C, and you can say in GraphQL, I want to run operation query B, and it can do that. But in terms of actually emitting multiple actual schemas at the top level, doesn't really exist to my knowledge. You would need to first dip into the query from the root query, that first initial object that you have at the top of the graph, and then you could potentially attach it to multiple completely separate schemas with the rules that you need to be able to introspect down the entire system.
Yeah. Can you define those schemas on the fly as a separate request so that would use them in the future requests, sort of like defining a shape of the objects?
So the schema itself needs to be defined before the beginning of the request, essentially, because of the sort of rules of the system with both the typing and the introspection. But you can do a fair amount with when you are actually querying how you want to model that. So in most of my examples, it's basically database rows, but in other examples, they're a bit more context-driven. I want the user if the user exists, but if it doesn't exist, I still want to be able to query things underneath this. And so you can use less database-driven approaches or data-driven approaches and just have sort of functional or logical ideas like viewer if it's there, or whatever makes sense. And then underneath, you can change potentially how those fields will act. So you can have a slightly dynamic resolution. You can have dynamic resolution, but your actual schema should be static from the get-go.
Do you ever have to do the reverse kind of a problem where you have a schema and you have data that, and you want to determine whether it actually could be a response to the schema, to this request, whether it actually, can you validate it against this?
So in our case, most of the validation and concerns are all done in the GraphQL side, just because of our mildly naive data side, I guess. But there's nothing stopping you from sort of inverting that. Like I kind of mentioned, you can, if your data model is very solid, or you're happy with the sort of validations that you get from that, or you already have an abstraction, you can rely on that instead of putting it into the sort of intermediary between the query and the actual data. So like, for example, like Facebook's TAO system, they're like, Facebook object system, that maintains all of the can Kyle see so-and-so, can Kyle, and that manages all that, and so GraphQL is just built on top of that. Because we don't have that like really strong type data model underneath, we're adding that on top. So we're kind of conflating two things in our GraphQL setup right now. But yeah, you can definitely rely on the data side if it's there and strong.
Okay, thank you.
Yeah.
So how much coordination does it require of, like, I don't know if you have only one team that's serving up the GraphQL APIs, or if there are multiple contributing. Is there modularity, and how does that work?
Yeah, so there's a team that's responsible for essentially like the framework of it, and the ultimate deliverable, I guess is how I would describe it, since that deliverable can be inside or outside of the company. But the teams across the company, probably like 30 or 40 teams, all build schema, build resolvers, are actively in making the system work. And so what becomes important is that the objects, when they're defined, are really relatively atomic and isolated. Like you don't want one object to really take up too much of the entire system, because then otherwise you're going to have these huge complications where people are trying to jam a bunch of data into a single object. And so what becomes tricky is really just modeling your data in the way that makes the most sense to someone querying it, which is different than how most of us probably model like data at scale, which is kind of like, oh, I want this to perform well, and so I'm going to jam this data all over the place. But with GraphQL, you're really trying to optimize it for, okay, if I were to ask for that, I want to go from a user to a profile and not just have it be like all the data on the user, or I want to go from an author to a kind of so on and so forth. Like you have to think about it more like how the person would be that queries it, which lends to less sort of conflicts where teams are both actively working on like one single object or one single field. I think the introspection side has helped discovery a fair bit to help keep people from building the same exact thing over and over, which is something that kind of happens in normal larger teams. So I would say that it's not really, it's as modular as you want to make it underneath the covers. And so for us, every object is its own file, which kind of gives us the beginnings of like a good piece of separation. And then when you have repeated logic amongst those objects, for example, counts, anywhere you see a count in our API, it calls one thing, because that way later we can optimize that one thing. And so that helps us kind of keep things from overlapping, but again, it hasn't been a concern yet, but in a year it might be.
Can the files deploy independently, or are you doing a coordinated change of like the whole thing together?
Yeah, so it can deploy independently, because of right now, all of our queries are in process, and so that single process will only be able to access that single schema, which is guaranteed to be up to date. The problem comes when we take that API out of process. So if you're doing single page app or whatever, where you're deploying and you're expecting that to be there and it's not, there's a couple different ways that you can go about doing that, besides just sort of this, like we'll just push aside the standard staged approach of deploying stuff. Facebook and a lot of other companies persist their queries. So instead of having the client go, this is the query that I'm going to call, you have the server persist that query, and then you give the client an ID, a hash, a thing that they go like, I want to run this later. And then when the request comes in, it's essentially GraphQL/persist and then the ID. It gives you a little bit of flexibility around knowing that the server has the things that you need instead of letting the client kind of do that, because then when that request comes in, you can be for sure that everything's rolled out or that we're no longer using these queries, and it gets you through some of the problem where the queries can change over time, or you don't know what your sort of query setup is. And so Relay Modern that just came out like yesterday, I think, has like this in as a first class concept where you can do like GraphQL persist, and you do that instead. That helps get around some of the deployment problems that can come, but because we're in process, we don't have to necessarily solve the model where the API isn't updated but the front end is. That would have to come down the road.
Okay. And how about the modeling? Is that something that the teams are able to do on their own, or are you finding that like a centralized team needs to be the modelers?
The gatekeepers?
Yeah, exactly.
So we do have like the gatekeepers, but we're trying to automate as much of the rules as we can as we sort of find our flavor, Like for us, like Booleans always have to start with is, and that's like something that's very easy to solve. The field names shouldn't have the type name in them, like things like that, which we can kind of go and do automatically. And so I think at first we were hesitant to add too much automation in because we wanted to sort of find our voice in the system first, but we still do automatically ping our teams so that way we can kind of read through it. And then every so often we do a sort of complete schema review of our internal schema, since it's easier for us to change and go, oh look, you're calling this URL and you're calling it _URL or like whatever. And we can kind of do that before it goes public, because once it becomes public, we run into the breaking change problem. And so we do these sort of automated systems, people systems, and then time systems to make sure everything sort of matches up.
Awesome, thanks.
Yeah. Sure.
The token scoping that you mentioned, is that internal or part of GraphQL?
Internal. So GraphQL has no cares about authentication or authorization. So different companies solve it in different ways. So if you're using OAuth or you're using a different type of authorization mechanism, that's completely on you and how you want to map that to your system. I'm happy to hang out if folks want to come up and ask questions, but it is late and I want to let everyone else go. So thank you so much. Come grab stickers.